So now we're going to work a problem with root locus. I rewrote all of our rules and how we talked about them. When I wrote it out before, I think I did not include the odd number here for the real axis. This to the left of the odd number of poles. I explained it, but I didn't write it down correctly, so it's written here. And we most recently, the last video talked about, was looking at the asymptotes and what happens when we have infinite zeros. So now we're going to try a problem, and Valerie has volunteered to write a problem down. So she told me I had to turn around and she'll write it down. So, all right, are you done? Oh, that was fast. Gosh, she's fast. Okay, so let's solve this problem. So, and draw the root locus for it. Here is our equation. We have it of g of h. Check to make sure that that's what we're modeling here. Great. So now we need to find the zeros and poles of the system. So for our zeros, I'm going to write here, zeros, we have none. So we'll wait. We'll look at the poles first. So poles, we have locations at -1 and -2. So we have 0 if we have 2 poles, and so we expect 2 zeros. So we're going to get 2 zeros at infinity. So infinity, let's write them like this, infinity. So we'll have 2 poles at infinity. So we need to understand where they're going to go, and we'll use these equations to figure that out. But first, let's just write what we know down on our plane here. So the S-plane, this is our imaginary, and we have a real. Okay, so first, let's just draw our pole. So we have one, we're going to say -1, -2, so -2, -1 here. So we have poles, so we're going to put x's there. Okay, so, and remember this is where we start, and we're going to end somewhere at infinity. But we'll do that in a second. First, let's look at the real axis rule. And so if we look at this, so here's our first pole. So to the left of that, this is our first one, that's 1. Left of that, there will be our root locus path. So I'll try to make it thicker so you can clearly see that that's a path. And then to the left of this, there's 2 to the right of these points, so no root locus path. So we have 2 here, but these are both our starting points. So we expect that they're going to come together somewhere and they're going to break off and go into infinity, which makes sense because we have our 2 zeros as infinity, but which direction do they go? To figure out that, we have to look at these 2 equations. So let's just write them down. So first, we have to find sigma. So this is the point on the real axis where our asymptotes will start. Okay, so we'll look at our finite poles. So we have these 2, we take the sum of them. So we go -1 plus -2, easy. Minus our infinite zeros, there are none of them, so we don't write anything. Our number of finite poles, here, they're the same. The number of finite poles is 2, so it's 2, minus number of finite zeros is 0. So what we'll get here, for our final expression, is we'll get -3 over 2. And if we map that point here, it makes sense, it's right in between, it's a -1.5, it's right in between our 2 points here. So this one ends up being right in the middle. So this is our sigma. And now we have to figure out what angle they're going to branch out in. So in this case, now we're going to apply it to this rule. So we know we have a 2 on the bottom because we already calculated that. So let's write, I'm going to write it over here. So our theta, we'll have something on the bottom here. We'll have a 2. And now we have to plug in some values of k into here to figure out what we're going to do. And here I'm writing pi. We can also write it in degrees. I'll write it in degrees this time. So now we have 0. It's just going to be 180 degrees, which is going to be equal to 90 degrees. Okay? So that's one of our axes, which makes sense. It's going to go in the 90 degrees. And by the symmetry rule, we know that it's actually going to be -90 as well. But just for completeness, let's throw in a k equals -1 and see what we get. So if k equals -1, so this is our first angle, we'll do our second angle, still over 2. We've throw in k equals -1, we get -1 plus 1, so it's a -1. So negative pi is -180 degrees. Okay, so then of course this equals what? -90 degrees. So these would be our 2 points, our axes, and we'll see that these will indeed go off like this in a straight line. So they go to this point and then go straight from here and out to, this would be positive 90 and negative 90. Okay, so this, starting from here, our poles go inward, they meet up in the middle, and then they go up and down at positive and negative 90 degrees. Positive and negative 90 degrees. So that is our root locus for this problem.